Hey guys, we've reached that point, we're ready to do some new maths. So hopefully you've watched the 2 introduction videos. We are now in our first practical, if you like, video of the proof playlist. So in this video we are going through consequence and equivalence notation. So things like this, where we got A and then arrow and then B. So, what does this mean? Very good question. So, first of all, if you look at this guy, so here I've used equal signs with a little pointy arrow on the end, which is absolutely fine. So, here then we've got A with an arrow pointing at B. How do we read this? What does this mean? Well, first of all, A and B are going to be separate statements. So A is a statement, B is a statement. So we would read this notation as A implies B. What does this mean? Well, this means that if statement A is true, then statement B has to be true. So A implies B. If A is true, then B is true. But it doesn't work the other way around. This isn't saying if B is true, then A has to be true. That's coming up next. Okay, so next up, we've got A with an arrow pointing at A and then B. So we actually read this from right to left. Now this is saying that statement B implies statement A. So if statement B is true, then statement A has to be true. So B implies A. If B is true, then A has to be true. And then we have a double equivalence. Sure, here we got A and B with a double pointed arrow sat between them. What does this mean? Well, this means A implies B and B implies A. So if A is true, B is true. If B is true, A is true. Now, we've been dealing with things like this for a very long time now. Any time that we've written an equal sign between two sides of an equation, or an identity sign between two sides of an identity, we have been dealing with this sort of equivalence, where one side implies the other. So the left side implies the right side implies the left side. We can also write this as A, I, F, B, which we read as A if and only if B. We could also write it, so we can write it as A if B, or we can also write it as B if A, if we really wanted to. So now we're going to have a look at some examples, some non-mathematical examples. First of all, to get us used to the idea of this notation, and then we will get some maths involved too. Okay, so we've got 3 sets of statements to work out the equivalence of. So, first 2 statements. Statement A, I am 28. True story. Statement B, I am in my 20s. So, do we have any implications here? So, if I am 28, am I definitely in my 20s? Yes, I am. So, we at least know statement A implies statement B. Now, we have to check the other way around. Does statement B imply statement A? So, if I am in my 20s, am I definitely 28? No, I might be 20, 21, 22, 23, for example. So statement B does not imply statement A. So the implication here is A implies B. Okay, next up. Statement A, it is June. Statement B, it is the 24th of June. So, let's check for equivalence. If we know it is June, does that imply it's definitely the 24th of June? No. Let's check the other way around. If it is the 24th of June, is it definitely June? Yes. So the equivalence here, or the implication, is that statement B implies statement A. If statement B is true, statement A is also true. But if statement A is true, statement B is not definitely true. It might be true, it might not be true, that's not definitely. So the implication only works that way around there. That way around. B implies A. Okay, and then for our third set, before the maths get involved, statement A, Tony Stark is Iron Man. Statement B, Iron Man is Tony Stark. So, let's check the equivalence here. So, if Tony Stark is Iron Man definitely Tony Stark? Yes. So, we do know that A implies B. On the flip side, if Iron Man is Tony Stark, does that imply Tony Stark is Iron Man? Yes. So, we've got an equivalence here where A and B are equal statements. They are identical. Statement A tells us Tony Stark is Iron Man. Statement B tells us Iron Man is Tony Stark. Those two statements are telling us exactly the same thing. They are equal. They are equivalent. We could even say statement A, if and only if statement B. Okay, hopefully that's shed some light on the situation. Now it's time to get the maths involved. Yay. Okay, first mathematical example then. So, statement A, n is positive. Statement B, n is greater than 10. So, let's check for equivalence here. Does statement A imply statement B? So, if n is positive, is it definitely greater than 10? No. Let's check the other way around. If we know that n is greater than 10, do we know that n is positive? Yes, we do. Anything bigger than 10 is positive. So, our relationship between these two statements is B implies A. Okay, let's look at another one. So, statement A here, x is equal to 1. Statement B, x squared is equal to 1. So, let's test. If we know that x is equal to 1, does that mean that x squared is equal to 1? Yes, it does. So, we know at least A means that B has to be true. So, A does imply B. Does B imply A? So, if x squared is equal to 1, is x definitely equal to 1? Well, let's have a go. If we set x squared equal to 1, if we square root both sides, we get x is 1, but it's not that simple, is it? Remember, when we square root, we get positive or negative. So, statement B does not imply statement A. So, B does not imply A, but A here does imply B. If A is true, then B is definitely true. Okay, next example, statement A, x plus 1 is greater than 0. Statement B, x is greater than or equal to minus 2. So, first of all, let's solve this inequality. In statement A, take away the 1, we get x is greater than minus 1. So that's really what statement A is telling us. Statement B is telling us x strictly has to be greater than or equal to minus 2. So, does A imply B? If x is strictly greater than minus 1, is it greater than or equal to minus 2? Yes, it is. By statement B, x is allowed to be minus 2 or anything greater than minus 2. Now, if we're talking integers, the first number that x can be by statement A is 0, which is definitely greater than minus 2. So we do know here, statement A does imply statement B. Does B imply A? Well, no. By statement B, x could be equal to minus 2, which isn't greater than minus 1, so B does not imply A. Okay, next up, so statement A, 18x plus 1 all over 5 is equal to 11. Statement B, x cubed equals 27. So, we're going to want to solve both of these equations. So let's do statement A first of all. If we first of all multiply through by 5, we get 18x plus 1 is 55. Then if we take away 1, 18x is 54. And then if we divide by 18, we get x is equal to 3. So that's what statement A is really telling us. So x is equal to 3. By statement B, x cubed is equal to 27. If we cube root both sides, we get x equals 3 as well. So, what type of equivalence is this then? Well, both statements have led us to the same result. X is equal to 3. So x being equal to 3 implies x is equal to 3. So the equivalence here is A implies B and B implies A. So either A is equal to B, A is identical to B, or A if and only if B. Okay, the final question for this video. I hope you've enjoyed it, found it useful. So this question is actually from the AS AQA paper 1 specimen paper from their website. So this is an actual exam question. So statement A is telling us x squared minus 6x plus 8 is greater than 0. Statement B is telling us x is strictly greater than 4. So the first thing we need to do here is work out what statement A is actually telling us. So in other words, we need to solve that quadratic inequality. Now if you're rusty on that, I do have a video called Solving Quadratic Inequalities. Check it out. Okay, so first thing we want to do is solve x squared minus 6x plus 8 is greater equal to 0. So we're solving that. To do that, we want to factorise. So we're going to get x minus 2 and x minus 4, which gives us positive solutions of x is equal to positive 2, x is equal to 4. So remember what we found there is the coordinates on the x-axis while the graph cuts it. So while the graph is equal to 0. So if we sketch that, we've got something that looks like this. So here, x is 4, here, x is 2. So we're trying to solve where is this quadratic expression greater than 0, or in terms of the graph, where is the graph above the x-axis? So we're over here, or we're over here. So, as is very common with quadratic inequalities, we've got two solutions. So, statement A is telling us either x is less than 2 or x is greater than 4. So now that we know that, we can now sort out our equivalence. So if x can be less than 2 or greater than 4, does that imply x is greater than 4? No, because x can be less than 2. So A does not imply B. On the flip side, does B imply A? So we know that if x is greater than 4, that quadratic expression is greater than 0. So yes, B does imply A. So our equivalence is B implies A, like that. Okay guys, congratulations. We've done our first bit of A-level maths. Hope you've enjoyed it. Hope you found it useful. Let me know down below in the comments. In the next video, we'll be looking at proof by exhaustion. Take care guys.